Okay, in this video I'm doing a medium level example of a quadratic formula. If you're struggling, you might want to go back to the easy example I just did on a previous video. So the medium example, again, I'm trying to solve this equation for x. It's a quadratic because it's got the biggest term is an x squared. All right, and so I can't factor this one. There aren't two numbers that multiply to -4, but add to 2 that I can think of, right? Not any obvious answers at least. So I'm going to use the quadratic formula. All right, so I'm going to just start off with x equals, and again, I'm just copying the formula using what a is, which is 1, b is 2, and c is -4. So it's opposite of b, which is -2, or opposite of b is 2, so b, -2, plus or minus the square root of b squared minus 4 times a times c, and c is -4. So I'm going to end up subtracting 4 times 1 times -4. All of that's over 2a, and a is 1. And then I'm just going to work on simplifying that. All right. So again, typically I just rewrite the -2 and then the plus or minus. And I said this in the last video, but I'm going to deal with whatever's under the square root altogether. So that's 2 squared, which is 4, minus 4 times 1 times -4. 4 times 1 is 4, times -4 is -16. So that's going to be 4 minus -16. 4 minus -16. 4 minus -16 is 4 plus 16, right? So that's going to be 4 plus 16, which is 20. All of that over 2 times 1, which is 2. All right, so let's keep going. We've got to deal with the fact that we've got the square root of 20. And this is why it's a medium example. The square root of 20 doesn't come out as a regular old integer, right? The square root of 20 is somewhere between the square root of 4 and the square root of 5. So we can simplify that. And so what I do with the square root of 20, as an aside here, the square root of 20 is the same thing as saying the square root of 4 times the square root of 5. Why? Because 4 times 5 is 20. Now why did I pick 4 and 5 and not 2 and 10? Well, I wanted to pick factors of 20 that are perfect squares. 4 is a perfect square. The square root of 4 is 2. Right? So I didn't pick 2 and 10 because 2 and 10 are not perfect squares. So this equals 2 root 5, or 2 times the square root of 5. So when I go over here, square root of 20 simplifies to 2 times the square root of 5. Where did the 2 come from? That was the square root of 4. So you can rewrite square roots that way. Fun fact. All right. Now this is how you'll check your answers in the back of the book when you're doing these problems, and you're like, well, my answer doesn't look anything like that. Well, it might just be simplified. So let's go one more step. This is where we can break this up into two problems, so I'm going to do that now. So it's going to be -2 plus 2 root 5, all of that over 2, and then the other one is -2 minus 2 root 5, all over 2. And so what's happening is I got this whole numerator is being divided by 2. This whole numerator here is being divided by 2. So these are the two separate problems, kind of like I did in the previous example, where when you get to that plus or minus, you break it into two problems, because you're going to have two solutions. So -2 over 2, and all of these in the numerator can be divided by 2. So I'm going to divide each piece by 2. So the -2 divided by 2 is -1, and then I have plus 2 divided by 2 is 1, square root of 5, right? -2 divided by 2 is again -1, and then this 2 over 2 is 1 as well, so it's going to be minus root 5. And these are our two roots, or zeros. These would be the places where it would cross the x-axis. You can see -1 plus the square root of 5. That would have been one of the factors I was looking for if I was trying to factor this. It's no wonder I didn't come up with that. Remember doing the diamond and box. You're trying to think of numbers that multiply to -4 and add to 2. Well, you'd be there for a while because you'd be trying to think of these two numbers, right? That wouldn't work out so well. It would be kind of tricky. So these are our roots, completely simplified. In the next video, I'm going to do one with imaginary roots that also have square roots. It's going to be kind of tricky. Stay tuned.